Hey everyone, welcome to Open House. So I think we'll get started. There might be some more people joining us, but we can start. So I'm Lauren Digiu. I'm an instructor in the Math and Stats department. We also have Dr. Jarrett Smith here. He's also an instructor in the Math Stats department. Hey Jarrett. So our plan for today is we're gonna first kind of show you what a calculus lecture looks like. So our colleague Claudia Maurer recorded a video ahead of time. So for the first 20 minutes, we're going to show you that video to kind of get a sense for what it's like to attend a university lecture. Of course, it's a lot different than if you're in person and you're in a lecture hall with hundreds of students, but in any case, it'll be a sample of an online lecture. Then we'll transition to talking about some tips for succeeding in university. And then in the last bit, we'll open it up to a Q&A session where you can ask Jarrett and I anything. So before we get started, I'd like to take the opportunity to acknowledge the traditional territories of the people of the Treaty 7 region in southern Alberta, which includes the Blackfoot Confederacy, comprising the Siksika, the Kainai, and Kainai First Nation, as well as the Tsuut'ina First Nation and the Stoney Nakoda, including the Chiniki, Bearspaw, and Wesley First Nations. The city of Calgary is also home to the Métis Nation of Alberta, Region 3. All right, so this is Claudia, and she recorded this video. So it's a sample of a calculus lecture. So I'm gonna resize my screen so that you can see this.
Hello, everybody. So in today's lecture, what we're going to do is we're going to introduce the limit definition of the derivative. And in doing so, we're going to recall a couple definitions of slope, secant line, and tangent line, and we're going to use these and the idea of limits to define the derivative and differentiation. So what we've been talking about up until this point is we've been talking about limits. So the intuition behind them, how to calculate them, how to visually understand what they mean, all of that kind of stuff. But now what we're going to do is we're going to make this shift into focusing on derivative and this process of differentiation. And so this set of notes is really going to be this bridge between what we've been talking about, limits, and this idea of what a derivative is. And specifically in this set of notes, we're really going to focus on this idea of finding the slope of a tangent line. This is going to be really important in understanding what a derivative is and what it allows us to do. So before we jump into the definition of the derivative, let's just do a bit of a review of a couple terms that hopefully everybody is somewhat familiar with. We're going to talk about the slope, we're going to talk about the secant line, and we're going to talk about the tangent line. So let's start with the slope first. If we consider just a regular line defined by the function f of x, then when we talk about the slope of this line, we're really talking about a ratio of change. So let's say I just had a line here. What the slope represents, or what the slope is it's a ratio of change in our vertical motion, so the change in our y-axis or y distance, over the change in our x-axis or horizontal motion. So if we think about the slope, basically the idea is if we have 2 points on our line, we can calculate the slope by looking at the ratio of the rise over the ratio of the run. So that's typically how people think about the idea of the slope. So rise over run is kind of a common way of remembering the calculation of the slope. Now, one thing that is important about the slope, usually it's denoted m here, is we do need 2 points to define it. So notice here we have an x and a y coordinate for one of our points, maybe this one, and an x and a y coordinate for maybe the other point here. And so, again, it's this idea of a ratio of amount of change in our y and our x points or coordinates. So for a straight line, the slope is constant, so I could pick any 2 points on this curve and I would get the same slope. But when we talk about anything other than a straight line, this curve, this non-straight line, will usually not have a constant slope. And it will change from point to point. So maybe I had a curve like this. The slope here might be different than the slope here versus the slope here. But we can still talk about calculating the slope at any given point by considering the slope of the tangent line at that point. So when we talk about the tangent line, we're talking about a line to a curve defined by our function, and it's the line that intersects the curve only at a single point. And the nice thing about the tangent line is that the tangent line's slope is going to equal the slope of the curve where that tangent line touches the curve. So you can think of the slope of the tangent line, I'm going to denote it m sub tan, as representing the instantaneous rate of change of f of x. In other words, at that particular point, how much is the rise changing compared to the run? It's this idea of instantaneous rate of change, and that's going to be really important to us as we go forward talking about what the derivative is and what that allows us to do. So just as a visual of what the tangent line represents, here's a picture. We have a function in blue, that's just f of x is x squared, and this red line is representing the tangent line at x equals 1. So here's our x value of 1, and we can see that this tangent line just touches our curve right there at x equals 1, and more specifically at the point 1, 1 in this case. So maybe we wanted to find the instantaneous rate of change of this function at x equals 1. So to do so, like we were just talking about, we would need to find the slope of this tangent line. But how would we do that? As we talked about above, to find our tangent line, or to find our slope, we actually need 2 points. We need our point sub 1 and our point sub 2 in order to plug it into this formula here. But in this example, notice that we only know 1 point through which the tangent line passes. We only know it passes through 1, 1. So how do we use that 1 point to find the slope of the tangent line? Sounds like we need 2 points, so how do we do it with 1? Well, this is where the idea of limits can help, as well as this idea of a secant line. So if we think about a secant line is a straight line that passes through 2 points of a curve. So to continue on with this example here, let's say we have the same function f of x, and again, this is the point that we're concerned with here, this point at 1, 1. But let's go ahead and construct a tangent line that passes through the points 1, 1 and 3, 9. So it passes through 2 points on this curve. And we could easily calculate the slope of this secant line by calculating the difference in our y-coordinates over our x-coordinates. So here, if I treat this as my y sub 2, or my point number 2 and my point number 1, I'm going to get 9 minus 1 over 3 minus 1, which gives me 8/2 or 4. Now the thing about the slope of the secant line is it actually represents the average slope of this curve between these 2 points. So that 4 is like the average rate of change from point 1 to point 2, 1, 1 to 3, 9. But that's not quite what we want, right? We want the instantaneous rate of change. We want the slope at a single point. So rather than wanting the average slope, we want the instantaneous slope. So how do we go about that idea? So here's again where this idea of limits can really help us out. I'm going to scroll down and kind of talk through this here. So here's another picture with a couple different lines going on. Originally what we had was our point 1, 1 here and our point 3, 9 here. Let's take this second point. Let me use a different color. Let me use pink. And let's slowly bring that closer and closer to the point of interest along our curve. And as we keep moving it closer, we're still going to get new secant lines each time. But each secant line's slope is going to be a better and better approximation to the slope of the tangent line. So here, if I bring this point all the way down to here, notice that here's my secant line. It's getting closer and closer to that slope of the tangent line that I want. So the further I bring this point down, the closer that my secant line slopes get to my tangent line slope at that point. So in other words, I'm taking this point and I'm bringing it basically right on top of that point of interest to get a better and better approximation of the slope of the tangent line. So now let's see if we can phrase this in terms of limits. So let's say our 2 secant line points are x and f of x, so that's this guy. And then let's let our second line, or our second point, be defined by x plus a little bit of distance, plus, let's say, h, which means our y-coordinate is going to be f of x plus h. So this point here is x plus h, f of x plus h. And the idea is that we want this distance, this extra bit of distance between the two x-coordinates and y-coordinates to go to 0. So if we make h smaller and smaller, our second point is going to go to our first point, and the slope of the secant point, or the slope of the secant line, is going to go to the slope of the tangent line. So more specifically, in terms of limit notation or a limit definition, we can say the slope of our tangent line is actually going to be the limit as h goes to 0 as we bring that second point on top of the first. So notice this is the y-coordinate of our second point. Here's the y-coordinate of our first point. Here's the x-coordinate of our second point. Here's the x-coordinate of our first point. Notice that's the definition of the slope. That's the calculation of the slope. It's just in this case, we're using slightly different notation. And this is really where this idea of the derivative comes from. So if we simplify this a little bit and write it as f of x plus h minus f of x over x plus h minus x just ends up being h, we basically have our limit definition of the derivative. If f is a function defined around a certain point, let's call that point A, we say that f is differentiable at that point if this limit exists. The limit as h goes to 0 of f of a plus h minus f of a over h. And this limit is the derivative of f at a. And it's typically labeled f prime of a or f prime of x if we don't have a specific value of x in mind. And the process of taking the derivative, or the process of finding the derivative, is called differentiation. So in other words, if we differentiate a function, what we're doing is we're finding its derivative. And more specifically, in terms of the visual of what's going on here, or the representation of what the derivative is we're finding the instantaneous rate of change of our function at a certain point. So when we take the derivative of, say, this function, if we find f prime of x, or more specifically in this case, f prime of 1, what we're doing is we're finding the instantaneous rate of change of this function at this point. The slope of the tangent line gives us the instantaneous rate of change of that function, which we won't talk about that in this lecture, but it has a lot of real-world applications and a lot of really interesting and useful and important real-world applications. So what we're basically doing here is we're finding a way to get our instantaneous rate of change really just based off of a single point. But because we know this idea of limits, we can actually define the idea of instantaneous rate of change in terms of limits. Now, one thing to note is there are actually a couple ways of expressing the limit definition of the derivative. One way is this form here. You can also see it written in this form. So this form is exactly the same. The only difference is that instead of writing h, we're substituting x as a plus h. So that's why our denominator here ends up being x minus a. If x equals a plus h, then h, our denominator up here, if we solve this thing for h, it becomes x minus a. So let's actually find the limit definition of the derivative, or in other words, let's use the limit definition of the derivative for a specific function. And let's actually use it here in example 1. So here we want to find f prime of a for f of x equals the square root of x plus 4 at a equals 5. Now this is new notation for us, so let's kind of decode what that means. This thing, this expression, is telling us to find the derivative of our function specifically when x is 5. So we want the derivative of our function at x equals 5. So that's what that expression means. And of course, this is our function here. And this is just saying the specific value of x that we're interested in. Now, of course, there's a couple different ways I can do this. I can use either this form here, or I can use this form. Let's actually go ahead and use this form here. So I'm going to take this limit, and I'm going to use this is the limit definition of the derivative, to find the derivative of this function at x equals 5. So just so that I have it on this page, I'm going to go ahead and rewrite that expression of the limit definition of the derivative. F prime of a can be found by taking the limit as h goes to 0 of f of a plus h minus f of a over h. All right, so let's see if we can fill in this form of the limit definition of the derivative and then see if we can figure out the limit. So I'm taking the limit as h goes to 0 of this thing. So let's start with this piece. I'm going to go ahead and color code this. F of a plus h, what that means is every place I see an x in my function, so in other words, every time I see this in my function, what I'm going to do is I'm going to replace it with a plus h. So every place I see an x in my function, I'm going to replace it with a plus h. So for this first piece here, this is going to be the square root of x. X is a plus h. And then I've got that plus 4 there as well. Then I'm going to subtract from that f of a, which means every place I see an x in my function, now I'm going to replace it with a. So I'm going to subtract the square root of x plus 4. X is a, so this is going to be a plus 4. And then my denominator here is just h. No x's, no a's, so I'm just going to put an h there. Now let's see if we can simplify this a little bit to make it a little easier to work with. I know what a I'm interested in. Specifically, I'm working with a equals 5. So I'm just going to go ahead and rewrite this and put a 5 every place I see an a. So this is the limit as h goes to 0 of the square root of 5 plus h plus 4 minus the square root of 5 plus 4 over h. Now it looks like I can simplify this a little bit more. It looks like there's some quantities that I can add under these square roots. So this first one is the square root of 5 plus h plus 4. That's the same thing as 9 plus h. And this piece here is the same thing as the square root of 9. Now square root of 9, that's just 3. So one more time before we do anything else, I'm going to rewrite this as the limit as h goes to 0 of the square root of 9 plus h minus 3 over h. So I've simplified things quite a bit here, but notice that if I try to take my limit, I'm going to run into the issue of my denominator here being 0. Since I'm taking the limit as h goes to 0, my denominator would be 0 there, which is something that we don't want. So what I'm going to do is I'm going to use one of the techniques that we've learned to help us with rational functions like this, where if we just try to use the substitution rule, we might run into some trouble like we do here. And notice that since I have a binomial expression here in my numerator and one of them has a square root in it, one technique that might help us out here is rationalizing the function, or multiplying both the numerator and the denominator by, in this case, the conjugate of the numerator. So I'm actually going to go ahead and multiply both my numerator and my denominator by the conjugate of the numerator. So the conjugate of this numerator is going to be the square root of 9 plus h plus 3. And I'm just going to do that multiplication for both the numerator and the denominator. So if I FOIL out that numerator, what I'm going to get is square root of 9 plus h times itself is going to give me 9 plus h. My outermost terms are going to give me plus 3 times the square root of 9 plus h. My innermost terms minus 3 times the square root of 9 plus h. And then my outermost terms are going to give me minus 9. And I'm just going to leave my denominator without doing anything to it. I'm just going to rewrite it here. Now I have some things that cancel out a little bit here. This part and this part are going to cancel each other out. I also have a 9 minus a 9. So it looks like my numerator is going to simplify quite a bit. I'm going to get the limit as h goes to 0 of, my numerator is just going to end up being h. And my denominator is still this whole thing here. H times the square root of 9 plus h plus 3. But now look what we've got. We've got an h on our numerator. We've got an h on our denominator. We can cancel those two out. And if I rewrite this one more time, notice that in my denominator, I'm no longer going to have that issue of the denominator going to 0 if I take my limit. In other words, I'm finally to the point where I can use the substitution rule and just plug in a 0 there for h. So I'm going to drop my limit notation here because I'm finally taking the limit. I'm finally plugging that value in. And I'm going to get 1 over the square root of 9 plus 0 plus 3, which gives us 1 over the square root of 9 plus 3, which is 1 over 3 plus 3, or 1 over 6. So this quantity, this limit, is the derivative of our function at x equals 5. Or in other words, what the derivative represents, or what it shows us, is that this is the instantaneous rate of change of my function at the point x equals 5, or when my x-coordinate is 5.
All right, so that was a sample calculus lecture by Claudia. So Claudia, Jarrett, and I are all teaching calculus this semester, and this week we're doing the limit definition of the derivative. So it's kind of a little preview of what our classes look like, although we're all in person this semester. So yeah, thanks Claudia for putting that together. So now we're going to move on to a tips for succeeding in university. And then we're going to open it up to a Q&A period where you can ask us anything. So a couple just kind of generic tips. Again, I'm a calculus instructor, so this is a little bit through the lens of what we see with our first year calculus students, but I'm sure it would kind of generalize to most university courses. So one thing that's kind of a big change between high school and university is just kind of the time and how much time you spend in class versus outside of class. So typically university students spend about like 5 to 8 hours a week on each course outside of class. It of course depends on the week. It depends on whether or not you have a test coming up, but it's a lot of time outside of class and not as much time in class. So for example, in our calculus class in Math 265, we see students in class for 2.5 hours each week, but then we expect they spend about 6 to 7 hours each week outside of class working on assignments or practice problems. Usually there's some things for university classes to do ahead of class, like some readings or some exercises, and then things to do after class, like quizzes or assignments. So what are some strategies for success? So here's a few. So I would recommend when you get to university to put like all assessment deadlines in your calendar. Usually at the start of the semester, your professor will list out all assessment deadlines on the first day in the course outline. So I would kind of just put all those in there just to kind of help organize and manage your time. Another good strategy is to take big tasks and to break them into smaller chunks. So sometimes the hardest part is beginning a task. And so if you kind of break it into a small manageable piece, then it feels good when you complete that smaller piece and you can kind of cross it off your list. So I'm a list person, so not everyone is, but I really like to make a list and it feels good to cross things off. So that would be one strategy. And another one is to just make note of which assessment deadlines are firm and which have more flexibility. So your instructor will usually be pretty clear about this at the beginning of the semester. If they're not, you can always ask. So for example, like midterm dates, those like you have to be there for, but maybe lower stakes assignments, there might be a little bit of flexibility built in. So it's good to kind of just make a note to yourself, which ones have more flexibility. And if you do ask for an extension, I would recommend not asking the day it's due. Try to ask early if you have like, maybe a sports thing, or like your instructor will appreciate it if you're kind of organized and ask ahead of time, to take ownership and be respectful when you ask, and don't assume that it'll be granted. So there's some assessments that the deadlines are just firm, like when the key gets posted, it's maybe too late to accept late submissions. So just to kind of be clear about what the expectations are. Okay, so another way that university may differ from high school is just the expectations. So it of course depends on your high school and what teacher you had and what instructor you had, but in general, university expectations often differ from high school expectations. And so for example, in university calculus, one major change a lot of our students see is in the types of questions we ask and the type of things they focus on. So for example, in my Math 265 class, everybody there has seen calculus in high school. So a lot of students have and did very well in calculus in high school. So they have like some study strategies that they know work well for them. But the difference is that the types of questions and things we focus on may be a little bit different. So for example, in high school, a lot of the questions maybe are kind of down here. If we think about organizing the difficulty of questions according to this pyramid, they're kind of more, do you remember the concept, understand it, and can you apply it to examples that you've seen before? Whereas in university, we ask those types of questions too, but we also ask more at the top of the pyramid, where not only do you have to remember, understand, and apply, but you have to have a deep understanding of it and be able to kind of analyze and do questions that you haven't seen before. What's the create part mean? Yeah, so create would be to maybe like create a proof of something. Evaluate would be like determine whether or not it's true or false. So kind of just taking all the things that you have and then applying it to other situations. It depends on the discipline as well. But so here's like a little chart, kind of like one strategy for being successful if the expectations are different is just to kind of acknowledge that the way you studied for something in high school might have to be modified in university. So in particular, this student in this table, they got very good grades in high school using their study strategies. And then when they took their first university tests, they got low scores. And so you might think that, oh, these are just outliers. And so like, it's not my study strategies because look at all this data. My study strategies work well. I have all kinds of data to back it up. But to just kind of acknowledge that the experiment has changed in university. And so your past data has to be kind of thrown out and maybe your study strategies adjusted just because the experiment is different now and our expectations are different. So how might you adjust your study strategies? So in addition to the ones that worked well in high school, like repeated practice or reading your notes, I would recommend that you engage in mindful practice. What I mean by that is to focus on the thought process and how to solve a problem and not just how to arrive at a solution. So sometimes I see this in the Math Help Center. So we have a Math Help Center where students can come to ask questions, and sometimes they have their assignment questions and they just want to know like, okay, but how do I get to the answer? and then I ask, okay, and then they get there and then I ask, well, how did you arrive at that though? Like, why is that the strategy that you used? And they say, I don't know. So they know how to do it for the specific situation. But if I gave them a problem that was just a little bit different, because they didn't really analyze the thought process, it's hard to apply that to a new situation. So to ask yourself questions like, why does this method work? What would I do if I encountered a slightly different problem? And what is this question trying to teach me? So kind of like metacognitive questions like that, to kind of understand the content at a deeper level. How many students typically per lecture? It depends. My lecture has 360 students. Some of the sections of calculus have more like 150. It kind of depends. So some other strategies for success include forming a study group, because the best way to learn is to teach someone else. So I would definitely recommend when you get to university to be brave and to make friends and to not try to study all by yourself. So I would recommend kind of reading each other's solutions to problems and pointing out mistakes that you see. That's a great way to kind of understand the content at a deeper level, and to also just monitor and evaluate your learning and adjust as necessary. So ask yourself, is this study strategy actually working for me, or does it just feel good? And also a growth mindset is super important, just sort of in life in general, but also within your studies. So what do I mean by that? So that's kind of just having an outlook that intelligence and skill can be improved with practice, to approach challenges with a positive attitude, and to embrace failure and view it as a learning experience. So in particular, why might you want to develop a growth mindset? There's lots of benefits, and I've listed a few on the slides. So in general, people with a growth mindset tend to be happier and less anxious when they're learning. They have more perseverance. They have increased confidence and motivation to learn, and they also do better, both academically and non-academically. And so some ways that you could develop a growth mindset is to say things like, I'm not good at this yet. Not that I'm inherently not good at it, but I'm not good at it yet. Or I did well because I worked hard, not because I'm naturally gifted. Or to just acknowledge that our brain is a muscle like any other, and it can be strengthened with practice. A couple other little strategies is just to keep on top of the material each week. So the pace is pretty fast in university. I would recommend that a few nights before the test, you really just want to be reviewing and not learning anything else. Start your assessments early so that you ask questions. So there's always lots of supports available for us to help you, but you have to start early and not ask kind of the night before, because even if you ask like a day before, our office hours kind of get busy there. So I would say start early if you can, and to try to mimic a test environment. So, maybe time yourself as you're doing some questions. Don't peek at your notes, would be a good strategy. And to also focus on materials that your instructor provides before seeking outside resources. So there's so many outside resources, which are great. Like if you don't understand the way that it was explained in class, then it's great to look at another, video or something. But I would just focus on like, what does your instructor think is important? Because they're the ones making the test. So I would focus on the problems they give you before you seek out other problems. And to also make note of your course's academic integrity policies. So this might be something that's different as well, in that we take academic integrity very seriously at the University of Calgary. And what this looks like depends on the course. So you might have one course and an assignment in that course where it's fine to work in groups and with your peers, and then maybe another assignment in that course where it's not. So just to make note of what the academic integrity policies are, and to ask questions if you're unsure. Okay, so one other major difference is the large class sizes. So someone already asked this question, but especially for our first year courses at the University of Calgary, some of the classes are very large. And in my section, I had 360 students in first year calc. In second year, the class sizes usually decrease. Like my second year linear algebra has 120 students. And then in the upper division, it's much smaller. And then in the whole course itself, there's over 1,000 students, and I'm the coordinator for Math 265. So like the ratio to instructor to students is pretty big. So with that in mind, though, there's lots of support available to you. It just might look a little bit different than in high school. So it doesn't mean that you should work alone. It just the way you seek help might look a little different. So form study groups, I've said that before, but definitely like rely on your peers and seek help from them. Take advantage of course resources. So this will differ depending on the course, but most courses have teaching assistants, labs and tutorials, and your instructor will have office hours. So definitely take advantage of those. I mentioned this before, but in the math department, we have a math help center for our first year courses. It's open like 38 hours a week. So there's lots of support available. And also just to be respectful when you email your instructor when you have a really large class, because they're probably getting a lot of emails. So just to be respectful. So how do they want to be addressed? Do they want to be called doctor, professor, or their first name? Does your course have an email policy? So some university courses will want content questions asked in person or on the discussion board and not through email. It depends on the class. And is it your answer available on D2L? So kind of a common theme through all these differences is that you have a lot more independence in university and a lot more onus on you to kind of like read the things. And so yeah, just a few little tips. And so finally, before we move to the Q&A period, I just want to acknowledge that university is super exciting and fun, but can also be stressful. So I just would recommend to be kind to yourself and to try not to stress out too much. Students in general put a lot of pressure on themselves, so give yourself a break. So I would say like if you get a bad grade in your first year course, it's not a big deal. Like especially if you go on to get very good grades in your upper years in your major, like nobody's gonna care when you apply for jobs. Personally, like my lowest grade was in my first year calculus course because like on my first midterm, I just my expectations weren't right, and I didn't do well. And now I teach university calculus and I'm an instructor, so like it didn't affect my career at all. So please give yourself a break, especially in your first year, first semester. Celebrate your successes, dedicate time for self-care, and also just don't be afraid to ask for help. So there's lots of great resources. University of Calgary has, for example, a student success center to help you out with study skills and things like that. So definitely ask help when you need it. So yeah, those are kind of my just tips. And now we're gonna move on to a Q&A period. So Jarrett is here as well. So he's also a calculus instructor. So I think I'll stop sharing my screen now and you can ask questions. So feel free to raise your hand if you want to ask them out loud, or you can ask in the chat.
The raise hand button should be located on somewhere under reactions on Zoom, depending on which version of Zoom you're using. So that's a great question in the chat. So you're thinking about pursuing a technology related major, using lots of math content. You don't love math, but you need to understand it. And what advice would you give? Great question. That's a tough one to start. I would say, you know, think about that goal that you have for yourself and try to look for things in those math courses that are relevant to you. So maybe if you're learning about something in one of your math classes and you're not sure what it's good for, you know, you can Google it and, you know, throw in some keywords about things you are interested in and see if there's any connections that can help you sort of build some of your own motivation for things.
Yeah, I would say it's definitely difficult to put the time in when it's not your favorite thing, because when you love the subject, when you study, it kind of just flies by. I find that if it's something that I don't like, even just for me, like breaking something kind of into chunks and then having a list, even if it's not my favorite thing, like I feel good to kind of cross it off and then like see the accomplishment kind of thing. So to just kind of make a schedule and get it done. But yeah, if you can find some motivation, that's a great suggestion. Other questions? What are you curious about? So are online resources such as YouTube or Khan Academy helpful? Yeah, I would say so. I mean, again, I wouldn't like rely on that as your first point of contact with the material, just because like they might cover stuff that your instructor doesn't, but like if you're not kind of just sometimes it just helps to see something another way. So I would say that it can definitely be helpful to kind of supplement things. Where can I find a recording of the session for later viewing? Yeah, so on the platform that you were using to access this session, my understanding is that it's going to be posted there afterwards. So after the session, I'm going to send it to the open house organizers, and I think they'll post it there.
Someone's asking about, are you, can you ask application related questions here? Absolutely, you can. Maybe we can answer them for sure. Would you recommend taking calculus during high school or wait to university? It's totally up to you and what fits best for your schedule in high school and your preference. If you want to see something twice, once in high school, once in university, that's great. But we do have a course called Math 249 that's designed for students that have not seen calculus in high school. We cover the same topics as Math 265. But we have an extra hour of lecture per week to provide some additional support so we can go get a little bit more contact and go through the material at more or less the same pace, but we have more lecture time.
There's a question, how difficult is it to transition from taking first year math courses to sciences or business if I choose to switch to that after my first year? Do you mean like how hard it is within your program to switch? I'm not sure I understand. Oh, Ashley just answered the question about where the recordings will be in the chat. Yeah, so if your question is about sort of just like what courses are required, then I would recommend asking like the Faculty of Science booth at the open house. So they would have like a lot more information about program planning. My understanding is that like there's quite a bit of flexibility and people change majors all the time. So I would imagine it wouldn't be that bad, but they'd be able to give you some more like concrete information about what courses you need and stuff and how those programs differ.
Yeah, the advisors at the Undergraduate Science Center can also help with some of the questions that are coming up in the chat about combined degree programs. The university calendar, which has all of the information about our different programs, can be pretty daunting to try to sort through. And so the Undergraduate Science Center advisors are a great resource to help you navigate what are the options for programs that can find the thing that fits just right for you, for your interests.
So would it help taking IB higher level course during high school, like Math 35? It can't hurt, I'm sure, but it's sort of up to you. I think probably those IB classes are pretty intense maybe. So I'm sure kind of if you learn it super well in high school, then it'll make calculus a lot easier in university. But there's lots of students who don't take calculus in high school that still do very well. So I would say it's certainly not required. Any general questions about the university experience, I guess, or what the first year classes are like? No content after Q&A. So this is just kind of an open Q&A period, kind of ask us anything. Will there be in-person classes from fall 2022 onward? That's hard to answer. I think that's the plan, but things are so unpredictable with COVID and stuff. But I mean, things are most like our classes are in person this semester, and we plan to be in person in the winter. But do you have anything to add, Jarrett?
I think right now, I think about 80% of our courses are in person, and it should be more in the winter. We're moving things back to in person as much as possible and as safely as possible.
If you need help from the student centers, do you make an appointment? Yeah, so do you mean like the Student Success Center and stuff that I mentioned and Student Wellness Center? So they all have, you can make appointments online through their website. It's pretty easy, yeah. But they take appointments and they have like one-on-one advising and stuff. Information about living in res.
So almost anything that you're looking for is somewhere on the University of Calgary website. It's just a matter of getting to the right webpage. So I was just grabbing a link here to the Student Services webpage for those of you that are interested in some of the services. So I'll throw that in the chat for you. I'm sure there's information going on today during the open house about residents as well. So there will certainly be other folks that can answer your questions about residents.
Yeah, I just Googled it and threw the resident services link in the chat. I don't know if that's the, that seems to have a lot of info there.
Great question about bursary applications that I don't think we know the answer to. Again, probably the science advisors will have the ability to connect you to the information that you need about those kinds of funding questions.
If we choose to, are we allowed to walk around the campus on our own time because the in-person open house was canceled? Yeah, I think so. I mean, outside of campus would definitely be fine. For visitors to campus, there's like a university policy. So I think that visitors to campus are supposed to be vaccinated, or do you know that, Jarrett?
Yeah, I'm just looking right now. I mean,
Okay.
Visitors to campus do need to provide proof of vaccination. So we currently have there we go, campus visitor information. I'll throw the website in the chat for you that has visitor information for the COVID-19 safety protocols right now. So that website should have some of the technical information that you need about coming to campus right now. Good question, Theodore, about program averages. So different programs have different GPA requirements to enter the programs and transfer between programs. Again, this is a great question for the science advisors, and most of this information will be in the university calendar. But the science, and it will change. Different programs have different requirements.
And there's a question, is there similar math support for upper level math courses, or is the expectation that you should handle them yourself through tutorials, etc.? So I would say that with our upper level math courses, the class size is usually quite small. So for example, I taught like a 400 level math course and there's only 23 people in the course. So it was sort of just, they could come to my office hours and that was mostly enough. Usually by the time you get into your upper years as well, you have like a pretty good group of students that you're working with. And so you have like some good support from them, but the class sizes are small enough in most of like our upper division math courses that it's easy to talk to the instructor and get help from them. And some of them have TAs as well. It depends on the course.
One thing maybe I'll mention, lots of first year students will be a little bit confused about what office hours are. So office hours are just times when your instructor is around and available for you to come and just ask questions. So office hours are just opportunities for you to come and talk to your instructor, ask questions about the material and how things are going.
Any other questions? All right, so if there's no other questions, then this might be a good time to wrap up since we're at 11:20. If you have other questions though, and you don't want to ask in front of everyone, we're happy to stick around for a few minutes and chat. But if there's no other questions, I hope you guys have a great rest of your day at Open House. There's lots of great booths and people to chat to at the Faculty of Science booth. And I hope you have a great weekend. See you.
Good question about